Hello, community. So today, a new multi-backend tool for building neural networks. It is called Keras 3. Now, what is Keras? Keras is a high-level API for building neural networks. Sounds easy. You know Keras 2 now from in TensorFlow 2. It was really focused on TensorFlow. But now here we have the opportunity to have Keras 3 also in PyTorch 2, or, and this is the interesting part, even in a distributed environment framework like JAX. So Keras 3 will come to TensorFlow, to PyTorch, and to JAX. And this is something beautiful. Let me tell you why. The main topic in Keras, our high-level API, we can build the layers of our networks, of our neural networks. We have all the complete control how many layers we build, how many self-attention layers we put in, how many self-attention head we distribute. We can define the loss functions. We can define all our optimizers. We can play around with metrics. So Keras lets us build here in a modular way our perfect transformer architecture, our perfect LLM. You have more or less 3 ways how to approach Keras. The simplest way is in sequential models, I will show you in a second. Then you have a functional API, which is a more powerful, if you want, tool. And of course, you can save and you can load your pre-trained model in Keras. And as I already showed you in my last video, model subclassing is a way to create really specific custom models that are based here on the available Keras model spectrum. And you can pick one model and just optimize 1 or 2 of its meta parameters, of its hyperparameters, or its layer structure, whatever you go for. This is an immense, powerful tool. As I told you, sequential class, this is the easiest. You build a model with 2 dense layers, you would do exactly this. Model, Keras.sequential, and then you have 2 dense layers. If you want a functional API, and you might say, why? Now imagine you have 2 sensors, so you have 2 inputs, or you want to share layers. This is where the functional API plays. And you might say, hey, wait a minute! Why have I to learn how to build neural network, how to build transformer architecture? Haven't you shown here in the last shorts that you published here? Llama 2 fine-tuning notebooks here. Llama 2 Hugging Face or the Facebook algorithm to fine-tune it. What about here the free Llama 2 70B chatbot? Or here, fine-tune Llama 2 with PEFT. And you said it's possible in 2 minutes. So why do I have to learn how to build those models? Yes, you're right. Here in the publication from Hugging Face that you see here on the right side with a very interesting cover, they have done something beautiful. They have here, and you see this here from Van Vera, they have here a beautiful GitHub where they have script that you just say, hey, take here a specific Python file, insert the Llama 2 model, for example, inside here my dataset that I want that the fine-tuning, the further fine-tuning happens, load here in 4-bit, use PEFT, and go. So you might say, hey, this 6, 7, 8 line of codes, and I can fine-tune a Llama 2 model. So, and then I just go to a cloud provider, rent out 8 A100 GPUs with 80 gigabytes VRAM each, and it's done. So why I have to learn this? Now, you are right. Yes, absolutely. There is this beautiful script here that, as you can see, is here. And we can simply load here from the Hugging Face platform all the different dependencies. Look, we have the transformer. We have here our auto model for causal language modeling. We have our 8-bit and 4-bit bits and byte configuration. We have the training arguments for our trainer. We have here from the transformer reinforcement learning here, specific trainer functions that are built by Hugging Face. And look, step 1, load the model. Step 2, load the dataset. Step 3, define the arguments. Step 4, define the LoRa configuration. And step 5, define the trainer. And then you are able here to go already here with just this some line of codes. And you are done. You have fine-tuned it on your corporate data, on your company data. So why learn here a complete new language? Well, imagine if Microsoft buys Hugging Face. What's then? So it is always great to have an understanding what is going on under the hood. All Keras model can be trained and evaluated on a wide variety of data sources. And they are independently of the backend we are using. I will show you a code example in a second. So all your data input, your input pipeline, what can you have as data formats? You can have NumPy arrays. You can have the classical old-fashioned Panda data frame. Yes, of course, you can go then for Parquet. You have your TensorFlow, your TF dataset objects. In PyTorch, you have your data loader objects. And I will show you there's an even high-level API structure of Keras itself, where they use Py dataset objects. And all their work together, whether we're using here the framework of TensorFlow, or you go for some distributed computing with JAX, or you use the classical development-oriented PyTorch environment. It works all over cross-platform. So if you say now, okay, I work here in PyTorch 2. I have here my data input, my data pipeline coming in, and I just showed you all the different formats. And then you say, starting this autumn, 2023, I will have Keras. Currently, Keras is in beta, so Keras 3 will come out in 2 to 3 months. And you are able to do this here. You define the architecture of your transformer. You define how each layer should be. Should it be a frozen layer? What about the weight tensor? You define your loss function, your evaluation. You can have here the perfect nitty-gritty for you. And then you have the same in JAX. You're working for a client who has a distributed JAX environment. And you say, hey, wouldn't it be great just to take the code of Keras and copy it one by one without changing a single character? And now with Keras 3, this is possible. So in whatever backend framework you work, PyTorch, TensorFlow, or JAX for your clients, your core, if you do it in Keras 3, is absolutely the same code that you verified that it works. The same here if you go from PyTorch to TensorFlow. Yes, your data input pipeline might be different because in TensorFlow, the data are handled in different formats, in different ways, but the core Keras 3 will be the same, and I think this is the amazing thing that is coming up this autumn 2023. So why not let's have a look at the code, how it actually works in our beta version. And you might say, yes, yippee, here we are. I'm using here this beautiful Jupyter notebook on Colab from François. Mr. Keras himself created it, you see here, end of 2023, and I just added a little bit of clarification to make it easy. So here we go. Now rename now runtime. Let's have a look what runtime I have. A Python 3, a GPU, a T4. This is all we need. Great. So first thing, we install here this new Keras functionality. Currently, it is called Keras Core, and of course, since it's developed by Google and it is based on something developed by Google, you will find it here in your Google Colab notebook. So, Keras Core, rather easy, and now comes the most impressive. You see, done. Setting it up, and we're going to use the JAX backend here. But if you see here in the environment command, if you substitute JAX by TensorFlow or by Torch, and you hit restart runtime, the whole notebook will just run the same. The entire notebook I'm going to show you now is backend agnostic. And I know you're gonna say, unbelievable, how could this be? Yes, this is the new idea. It doesn't matter anymore if you are a TensorFlow or a PyTorch or a JAX, whatever. If we can do something back-end agnostic, this is great. So we can work for all clients in their environments, and we don't have to change our main code for the architecture of the neural network. So let's run here on the JAX backend using JAX backend. Beautiful. So how do we start? Something that you know now. For example, here, our hello world. This is, we're training a CovNet on classifying MNIST digits. Let's do this here in real time. Beautiful. So here is the data done, and then we say here our model. As I told you, we have here the sequential API that we will use now in the most simple case. Then we have a functional API. I already showed you the code. If you want to share a layer, multiple input-output structure, or we do some subclassing as I showed you in one of my last videos. So let's do this. What we have? We have a simple Keras model, a sequential model that is optimized here for our task. Now, if you want to read here the functionality of each of this layer, I have here summarized this for you in some additional text you will not find in the official notebook, but this is for you. Pause the video, read it. We're just gonna have here, we execute here this command line, and you see we define our Keras model and we define each layer, and for each layer we can define its functionality. And this is backend agnostic, which is amazing. So if you want to see now here what we just built, the summary command, I highly recommend this to you. So you see here our layer structure. You see here the output shape and the number of trainable parameters that we have here. And you see immediately where a lot of the training parameters are available for training for the intelligence. Beautiful. Yes, if you want to freeze, this is just an input from me. If you want to freeze here specific layers, and a lot of questions I received is, hey, if I want to freeze here some specific layers, how I do this? Now, in Keras 3, this will be very easy. You just say, hey, for all the model layers, if, let's say, for example, the embedding layer that I choose now here within the Keras framework, I want to set this to frozen, block solid ice frozen. You simply say, hey, layer trainable is false. So you see, you can handle freezing and unfreezing of layers with a simple line of code. Yes, beautiful. Now the compile method. Here we, yes, thank you, I knew this. Here we specify, for example, our specific loss function, our specific Adam optimizer. Yes, we are still working with Adam optimizers. You're not going to believe this. And then we have here a metric for an evaluation. Here, for example, sparse categorical accuracy. But you are free to use whatever you like. This is really for you to build up your system. Note that with the JAX and the TensorFlow backend, the XLA compilation is turned on by default. And yeah, maybe we should execute this we have now. Yep, done. And then let's train and evaluate now our model. What we do, we see the batch size and the number of epochs. This, you know this. We have some callbacks, some checkpoints if you want. Beautiful. And then you have here the command. Now we're going to train our model. We have our training data set, we have the batch size, the epochs, the validation splitter, and our callbacks thing, and then we simply evaluate it. So let's do this in real time. Here we go. You see I use here a free Colab notebook with a T4. I set it to 10 epochs, and one epoch should take less than 5 seconds. Okay. First epoch is done. 16 seconds. Wow. So quite some traffic today. Here we go. 4 seconds. 4 seconds. Yeah, this sounds much better because I've chosen this example here that I can show you in real time. Because some people complain, hey, we want to see the complete run through of the epochs. Okay, here you have the run through of the epochs. But it's clear what's happening. And then if you say, okay, training is finished, now we want to save the model at the end of the training phase. Now, this is rather easy in Keras. You say just model save whatever you have and done. And if you come back the next day and you say, okay, now I want to reload this, what I have done, you have your model immediately available. And of course, you can make now the prediction. You have a specific data set that you want to apply now the model to with a prediction, and done. So really nice. Should we dive into this? Yeah. As I told you, Keras Core, as the beta version is called, enables you to write custom layers, custom models. You can modify the metric, the loss function, the optimizers in TensorFlow, in JAX, and in PyTorch. So isn't this great? Now, you are familiar, if you're coming from Keras 2, if you want here, in the TensorFlow implementation. And we have here for our custom layers here this typical TensorFlow.keras command. So you just exchange here the namespace in Keras 3. So all you do is simply you go now with Keras ops and whatever you want to put there. So let's have here a look. An implementation of NumPy. Keras ops stack or Keras ops matmal, a multiplication here of matrices. Set of neural networks, yeah, Keras ops binary cross entropy. You get the idea. If you want to make now a custom dense layer where each neuron is connected to each other neuron here, look, now you understand why I had this video on Python classes, because this is exactly how we're gonna operate. We have here our init method where we initialize here our specific class. And then we have here the build method where we say this is it. Then we have here our weights. And again, we have here our special call methodology. Beautiful. Yeah, why not do this? Execute this in real time. I will leave you the link to this notebook so you can play around yourself. Yes, okay. You can define now a dropout layer. You can build whatever you like. And then you build here simply a very specific model. You see now also here I have my Python class. I have here the subclassing. So my parent class is here the Keras model. And I'm gonna modify now certain specific items of this predefined model. And as you can see, we have defined here the dropout. And we have altered here my dense layer. So you're not going to believe us, but this is exactly what we are going to do. So you see here, I have here now my dropout layer and my dense layer with my definition. And this is it. So if we have now the call method, you see exactly what's going to happen. Let's do this. Let's compile it. Compile it. You know exactly the same is going to happen. And I hope I have 10. Yeah, should be. Oh, that's it. Epochs is 1. Well, epoch is 1 is a little bit boring. Let's do the 10 that we have some comparison. Okay, this is running. And while this is running, what I want to show you, you can, as I told you, now, if you're working in a framework, your input data, there's a lot of additional information. Maybe I'll make a second video that I show you if we have this Keras 3 functionality this autumn coming up. It is very easy then to have now arbitrary data sources where we work here on a multi-backend structure. You know, I just showed you NumPy arrays, Panda data frame, TensorFlow, PyTorch object, or the Keras objects. And then I can show you here, for example, We work here with the PyTorch data loader, how you can integrate this into Keras 3 with Keras 3 PyTorch. I think this is an amazing, powerful tool coming up here. So this is it. This was the very short overview. I wanted to show you what is coming in this autumn. If you are specialized here in PyTorch, if you like PyTorch, you will get a very powerful tool to build neural network architectures, to build different complex models with your specific layers, with your specific functionalities. You can train it, you can freeze layers, you can do everything that you want. And Keras 3 approaching autumn 2023. I will make maybe another 2-3 videos just to prepare if somebody is interested, and you will be able, whenever Keras 3 will be released, to take full advantage of this powerful new AI programming tool. I say thank you for today. I hope it was informative. It would be great to see you in my next video.